Hey y'all, in this AP Chem intro video, we're going to talk about sig figs, or significant figures, or significant digits, but sig digits doesn't sound, I don't know, sig figs, it just rolls off the tongue. So what is it? It's important digits, or important figures in a measurement. This last part is key. It has to be a measurement, as in it has to have a unit at the end, so like 34.5 meters. Just the number 34.5 has no sig figs in it because it's not a measurement. So things that are not sig figs, if there's no unit, or if it's an absolute. Like if I say I'm one person, then technically I'm like 1,000,000 for infinity. I'm never going to be a fraction of a person. There's no estimation there. And for no unit, I haven't estimated anything because I'm not measuring. So what is a sig fig, or what does have sig figs in it, I should say, is anything that's been measured. Now, whether it came from a measurement or was indirectly mathematically determined from a measurement. So for example, 35.4 meters has sig figs in it. If I say 4.2 times 10 to the 28th atoms, I've got a unit there, atoms, so that it has significant digits. So when you are taking a measurement, you are always going to look at the graduations, and you always estimate one digit past your graduations. You guys, you might hear my daughter Clara in the background. She's just really excited about sig figs, so sorry about that. So let's say we have this beaker, and it has 10, 20, 30 milliliters. So because our graduations or our check marks change by 10 milliliters, they change by the tens, then we need to estimate one more spot. So we need to estimate at the ones. So let's say I have this amount of fluid. I look to the very bottom. So I'm going to say this is 22 milliliters. I cannot say that this is 22.0 milliliters, and I cannot say that this is 28 milliliters, right? I have to look at the bottom because I have to say it's about, this is where I'm unsure, this I know. So I know for a fact that there are definitely at least 20, and I'm estimating 2 more. If it came to here, and I want to say that this has 10 milliliters, that would not work. We're going to come back to why that won't work in a second. All right, and then we'll figure out what would work for this one. So which digits are significant? So you're always going to start at the left and work your way to the right. The first non-zero is significant. So let's have a couple measurements, and let's say what the first sig fig is. So let's say I have 750 centimeters. Let's say I have 0.00750 milliliters. And let's say I have 75 grams. I don't know why I wrote out grams and didn't write out the other units. And let's say I have 7,500 with a decimal, let's say meters. So in all these measurements, the 7 is going to be the first sig fig because I start at the left and the first non-zero. So these guys are not significant. The reason these aren't significant is if I put this into scientific notation, then those all go away. Okay, so then every digit after is significant unless 0 at the end of a whole number without a decimal. So my first one has one of those zeros I'm talking about. This is a whole number, so it's one of our counting numbers, 1, 2, 3, 4. And then the 0 is at the end, so that's not significant. This only has 2 sig figs. So if I were to put this into scientific notation, these are the only 2 that would go into scientific notation. So this would be 7.5 times 10 to the second centimeters. And notice my sig figs are the only ones that make it into scientific notation. So that's a rule. Every number in your coefficient in scientific notation is significant. So this, my 7 is the first one, and then everything after it is significant because I have a decimal. The decimal says just go ahead and include everything. So these are all significant, so this would be 7.50 times 10 to the negative third milliliters. So this does not have a 0 at the end, so everything's significant. This would be 7.5 times 10 to the first grams. This has a 0, so that means all of the digits are significant. So this would be 7.500 times 10 to the third meters. All right, why is this important? So for this one, let's look at it. My last sig fig is always estimated. So this tells me that you estimated the 5 and you didn't estimate the 0. You just had nothing to measure that with, which means that in the 100th position, that's how your device is calibrated. So this is your calibrated number, and this is your estimated number. Okay? If I had something that said 751 centimeters, I know that I used a different device than here. This came from a more precise measuring tool because I have an extra sig fig here. That all 3 of those are significant. So this one was calibrated to the tens, right? This would be more precise than this. So going back, if I wanted to say this is exactly at 10 milliliters, I can't just write 10 milliliters. I would have to either write 10 with a decimal, milliliters, or I could put 1.0 times 10 to the first milliliters. So somehow I need to say that that 0 is significant because that's my estimated digit.